And let's take a look at the last page here. We want to find the centroid of this circle. So I think on question 14, I'm just going to do it algebraically. So I know the center is going to be at -3 plus 3 plus 0 divided by 3. Well, that's going to be 0, isn't it? And then I'll go 0 plus 0 plus 3, square roots of 3. Divide that by 3, and I'll get the square root of 3. I could do that geometrically if I so choose. Now, if I look at the in-center, well, the in-center I have to do geometrically. We don't have an algebraic way to find the in-center. So the in-center is the angle bisectors. So when I've noticed what I've done here is I've already plotted my points and I've drawn the triangle, and then I'm going to construct the angle bisector. So to construct the angle bisector, I just click on two sides, and it made more than I needed to there, but we can see the angle bisector going through A. And let me see here. How about if I do A to C to B? And then we can say my angle bisector is going to be at this point right here, point D. And if I go back and if I look at the point D, it says 0 and 1.7. Well, 1.7 is the square root of 3. So in other words, since this triangle is isosceles, the angle bisector is exactly where the centroid is, or the in-center is so it's 0 and square root of 3. The circumcenter is going to be my perpendicular bisectors. So let's go back here and let's take a look at my perpendicular bisectors. So I want my tools, my geometric tools, and the cool thing, I got this perpendicular bisector. I just click on my line. There is, notice it goes through point D again. If I click, and I couldn't see the other ones because they're exactly the same. Probably should change colors on that if we could. And so it's also at 0 in the square root of 3. Do you see where we're going with this? Since it's an isosceles triangle, and this is not cooperated again, so let me, there we go. So 0 in the square root of 3. Okay. And then the orthocenter, well, since the perpendicular bisectors go through the vertex, it's going to be the same. So, what relation do you, hopefully, what do you see? What do you notice? Well, I would say all the centers are the same in an equilateral triangle. That's the key. It's got to be equilateral. That's not true if it's not equilateral. But if it is equilateral, I know all my centers are going to be the same. And there we have it.